In this tutorial, I'm going to talk about aspect-oriented programming, a bit about what it is, why it's good for you, what types of frameworks support it, and different techniques that those frameworks use. And I'll give a demo of PostSharp, which is a leading framework using one of those techniques. AOP can be applied to many purposes, but the first concept to cover here of why AOP is needed is what we call cross-cutting concerns. What I'm going to show in this diagram is the classic way that those cross-cutting concerns are usually represented. So we have our application, which is in many cases built on an architecture of layers. We have the presentation layer at the top communicating with the user in some way. Then we have the public services, which in turn communicate with backend business components, which would usually communicate with some kind of data storage. Now, in parallel to all this, we have certain features which are cross-cutting, and actually what this actually means is that they work in parallel to the main code base at runtime. Things like logging, security checks, maybe some repetitive pattern implementations that we need, or transactions. And these are concerns, and they do take the focus out of the developer's implementation time. They clutter the code and they add a lot of complexity. The term here, cross-cutting, means that these features affect multiple architectural layers, and those of course are not nice-looking, smooth, monolithic layers as they appear in this diagram. There are actually many classes and interfaces and methods, and those so-called concerns have to integrate with many moving parts at the same time. So even this diagram being nice and smooth and well-formed doesn't begin to reflect the real world of what cross-cutting concerns add as complexity to a big project. So before I explain how AOP works, in light of the previous diagram, we can already understand what kind of issues AOP comes to solve. First, we reuse a lot of repetitive code, not just cross-cutting concerns themselves, but also their invocations and plugging them properly wherever we need it, especially in things like pattern implementations. We get a lot of boilerplate repetitive code, and every junior developer knows that copy-paste is the programmer's best friend, if you know what I mean. However, the second thing every junior developer knows after 2 weeks of copy-pasting is that pasting code is not just prone to errors, it always creates errors and bugs. And so we need to duplicate things in a safe way so that they always adjust to their context and usage. So one classical example, which we just mentioned, of such repetitive copy-pasted code everywhere is surely used across a big project, is what we refer to as cross-cutting concerns. There are many, the main concerns of the AOP developers are those cross-cutting ones naturally. Now, with all the reusable code everywhere, the power of AOP is to do all the work and leave the real code, the one which is not related to cross-cutting concerns, as clean and as readable and as neat as possible. Or as they just say in PostSharp, which is the framework that I'm going to demonstrate here, the size of code matters. All this, of course, helps improve readability. It reduces your work on reusable code. It can extend in ease to future modules and versions and deployments. So this is also helping with scalability and big developments. So back to the cross-cutting concerns and reusable code, which concern us. Let's see how those can be handled. So with the classic approach, we have many code files in the project, and we have the cross-cutting features that are usually implemented in their own encapsulated classes or modules or assemblies, and we integrate invocations to those cross-cutting modules wherever we need them in our source code. And then every time we need, for example, logging or security checks, then we just call the appropriate methods. As you can see here already, what this means is that we divert from the program's original flow. The code is moving to another module every time, and we clutter our code with many invocations, which actually don't really concern it. If we have a method that does a certain action and then it has to go out for logging and then it has to go out for a security check, this diverts the code and it really clutters it. It reduces the readability of the code and makes debugging more difficult, reading more difficult, and this integration just adds a lot of overhead to the clean code. Let's see some techniques that can resolve that. One classic approach which is used for adding behaviors to our code dynamically in runtime is using design patterns. A specifically popular one in such case is the Decorator pattern. Although decorator is just a fancy word for wrapper, developers would usually prefer to use it than to just say recursive wrapper, but the word decorator is much more fancy and hipstery, so they prefer it for some reason. And just to say that this class diagram is extremely simplified. Obviously it's not perfect, it's just to give the hint of how the decorator pattern works. Of course, in a real world you're going to have to add abstractions and intermediate layers and reduce couplings and all that. But what we can see here is we have an abstract base class worker, which is in common for both the concrete person class and the worker decorator, which is the base class of the decorators. So in essence, since all these classes share the same base worker, they are guaranteed to all support the same base methods, in this case the one called doWork. Also, each decorator has an instance of the base class, be it another decorator or a person, so they can essentially act as recursive wrappers, which means they can all invoke the other's methods in order. So we need to just call one the doWork, and it will pass through each of the other wrappers and execute their specific implementations as well, since they are just wrapping each other and calling the method recursively. This is a classic pattern. It doesn't require any framework in order to run it or to implement it. It can be implemented in any language. But with all that, it's cumbersome because the developer has to initialize the hierarchical wrapping and call the right methods at the right time. It's not transparent. It's not implicit in any way. But it does give a solution in this way. It's a form of aspect-oriented programming in this way. The next level of AOP is what we refer to as interception, which is usually implemented by frameworks which are referred to as dependency injection containers. What we do here is make things more dynamic. Those are built actually on the same idea of the decorator pattern, but they make it a bit more dynamic. It adds a few more features like resolving interfaces into classes in runtime. That way they can actually inject alterations to the original code flow of the program. So instead of going straight in the flow of our code, the code gets intercepted, for example, to call first the security module or to call a logging module before we continue the execution. So I'm not going to get into details of how exactly dependency injection frameworks work, except that what I already mentioned, that they have some dynamic wrapping, similar in its idea to the decorator pattern, and it has dynamic class resolution at runtime. Dependency injection containers are not just used for interception. As I mentioned, their great power is in dynamic resolution of interfaces and abstract classes into concrete types at runtime. This helps produce a better, more decoupled, more testable code with less effort. This feature is also part of the interception scheme. There are quite a few DI containers out there, but two which are widely used and worth mentioning here are, for example, are Castle Windsor and Microsoft Unity Container. They're both .NET and they're both free to use. The next technique is an alternative to the previous ones. This is also the topic of this tutorial, and I'll demonstrate how it works. And this is what we call IL weaving. So instead of being regular implementation classes and modules, our cross-cutting concerns are now being implemented in special classes called aspects. Once our solution gets compiled, in .NET, before it becomes binary code, it goes through the phase of being transformed into the .NET Intermediate Language, or IL. The aspects here get injected or weaved into the IL code at this point. Similar to the art of bacon weaving, we have nicely spread yummy combination. PostSharp is the leading tool to achieve this, and it's an up-to-date, well-supported, proven product with no real competition. It does its work great. And I'm going to show you just how easy it is to use it and how much clutter and work it can save you. So once this gets weaved and injected in compilation time, what we get is an intermediate language code weaved with cross-cutting concern code invocations inside it. This is done by PostSharp in compile time. You have to note here that if we disassemble our resulting binary files back to .NET source code, it will differ from what it was in the first place, since it's modified with additional toppings. But our original code here again is untouched, it stays neat and clean, and all those cross-cutting or repetitives or any pattern which is being implemented by our aspect is completely off our original code, and our code still, as we said, size of code matters. We are still with the minimalistic, easy to read, easy to maintain code which does exactly what it's supposed to. Let's see here a live demo of how to work with PostSharp and Visual Studio and how AOP can save you work and code. So here we are now in Visual Studio, just to show quickly how things work. This is my very simple Windows Forms application. It has nothing fancy about it, just a simple WinForm with a button and these two images which are also clickable. The core of my application model is the person class. So first thing you can see is that it implements the iNotifyPropertyChanged interface. This means that it has a respected event, which is the property changed, which has to be implemented by this interface. And I have to implement the notifyPropertyChanged method, which checks whether this event has been assigned, and if it is, it just raises it and triggers it. So in order to use that, I have a few public properties. First, I have a few private fields, which are the backing fields of my private properties here. So you can see each of those properties, whenever the setter gets called, I have to manually invoke the notify property changed with the name of the property. Here I have a small enumeration, just with these three simple actions in it. So every time one of those gets called, the iNotifyPropertyChanged interface kicks into action. The second thing I have here is two public methods, which I call work and read. And what they do is they actually change one of the properties as well. And the other thing that it has here is logging. So I have a logging of nlog. So I'm using in this project nlog, which is a free very good and powerful logging framework. Just makes logging pretty easy and powerful with lots of tools and lots of options. So for example, if I look at my application's app config, I have some logging configuration settings here. For example, I have a logging for trace logs, which I call trace log. And the trace log actually writes to a file which is named PostSharp Demo trace.log. Now back to my form, what it does, I have a private person member here, which in the initialization, I call the constructor and set a few properties to it. I also set a handler for the property changed here, which is this method. And what it does, it just shows a message box showing which property was changed and to what value, just using simple reflection. Then I have event handlers for the two images in the button. So here they are assigned. So when I click the button for work, I call the work method. When I click the button for read, I call the read method. And just a reminder what these do, they just change one of the properties of the person class and call logging. And once the property is changed, we have the property changed event handler, which calls the property changed method here. When I click the button for switching awesomeness, what I do, I go to the person's address property and change it from Sofia, Bulgaria to Prague, Czech Republic. And that's the entire application. So let's first see how it runs. Here it is. So when I click the awesomeness button, I'm going to change the address property, and this will trigger the iNotify property changed. And I'll catch it and show a message box. Here it is. Great. Now if I click the read image, I get the read property, the action property changed to read. And if I click the work, and that's about it. If we take a look now at our applications bin folder, we'll see that there is a new PostSharp Demo trace log that we can open, and we can see that nlog has traced our methods entry and exit, so it's exactly what we plugged into the person class. Let's delete this log for now, and let's make a few changes in the person file. First of all, when I hover my cursor over the person class, I get a few options which are integrated into Visual Studio from PostSharp. So let's say implement the iNotify property changed. So I get this very nice little wizard that all I have to do is click next and finish. Now the only difference in my class right now is that it added the using PostSharp directive, and it added this notify property changed attribute. This means that it now implements this interface implicitly, and I don't need the explicit implementation here. So I can remove this. I can remove this entire region of the iNotify property changed, and I can go into my properties. Let's do it here, and we'll just remove those invocations. Great. So now all our properties will automatically report notify property changed without me having to do anything. If I add more classes, if I add more properties, if I change anything, all I have to do is make sure that I have this attribute in place and everything else is working for me. So my code already looks much cleaner and much better. I can also remove this directive now. Next, let's add the logging. So let's again just click on the class and let PostSharp do its magic, and we'll say add logging. So I'm going to just log the public methods. It can also log constructors, and let's just add these. Let's just leave this as it is. Click next. Select the logging level, let's say the default on entry and exit, and just leave everything. I'm going to use nlog because this is the framework that I've installed here just as a very small NuGet package. So I'm going to leave it to that because that's what my project is already using. Just click next, and we're finished. So notice that the attribute is changed a little bit. So it says what is going to be logged with this little log attribute. So again, I'm going to just clean up my code. I don't need this logger anymore. And in my public methods, I don't need to explicitly call any loggings anymore. Now look at how my code is transformed into a super neat, super simple code. All I have to do is plug this into it, and the aspects will get injected into my implementation in compile time, and they will work as if I've put them there. This is great because I can work on a very scalable big project and I can inject this everywhere. I don't even need this log directive here. The only thing I have to fix now is in my form, since the person doesn't explicitly declare that it's implementing the iNotify property change, this will be implemented in compile time. So what I have to do is I'm going to just cast it now. So this will pass compile, and while it's being compiled, it will be injected with the right, weaved with the right code to make it work. So let's run the project again. And we'll see that the functionality actually hasn't changed. When I click, I get the iNotify property change raised, and then it gets collected by my form, and it pops up a message box. Also, when I click the images, same and the same. Let's look again at what's happening in the bin folder. I have again the same trace log, even though I didn't explicitly call any logging at all. So let's open this for a sec. And we can see I get a much more elaborate code here, a much more elaborate log here. So I can see the constructor being called. I can see all the properties being set. I can see entering and exiting each of the methods and each of the properties. So here I'm calling the person read. I'm actually exiting the person read, and I can see everything that's happening inside it. And all this again without adding any code into my class. It's much smaller, neater, and much easier to read, much more easy to use and to understand. One more thing I want to show here is, let's go back to the bin folder. I'm going to open a tool here called Telerik Just Decompile. This is a disassembly tool for .NET assemblies. It disassembles them back into readable code. So what I'm going to do, I'm going to take my built binary file PostSharp Demo exe and drag it. And here we're going to take a look at the executable, then into the PostSharp Demo namespace. And here's my person class. And look at that, it has a lot more than it had when I just built the code. It actually here implements iNotify property change explicitly. And if we take a look at some of those classes and methods, we can see that actually they have logging and many more statements just plugged into them. And this is uncomparable to what we had here and what it would look like if we had to implement this all ourselves. So these two examples of logging and iNotify property changed are the built-in demos and samples which are part of the PostSharp installation. But the real power of PostSharp is the fact that you can create aspects of your own and you can plug them in your own custom way. So what I'm going to show now is very, very simply how this can work. So let's say that we want to build an aspect that will implement security in our application. I'm going to add a small class here. Let's add class, and we're going to name it security aspect. Now you have to excuse me because I'm going to cheat a little bit and paste a little code here. But as you're going to see in a sec, it's going to be extremely simple sample code. Very small, again, minimalistic. And I'm just going to have to resolve this and this and remove what I don't need. So since this is this is actually deriving a class called onMethodBoundaryAspect. This means that this aspect will be triggered whenever I need it, whenever a method gets called, and it will inject its code whenever I need it. So on entry, meaning that when my method enters, I actually get directed here, and I'm going to run this code. So what I'm going to check is the thread current principal has a role of admin, and if it's not an administrator, I'm going to throw an unauthorized access exception with some details. This class has to be serializable. It has to derive a specific aspect of a specific type that you want to implement, and you should override the methods that you want. It's as simple as that, and the whole work of weaving into the IL code in compile time and running and doing its work at runtime is just what it is. So if I want to actually run this code, let's say that, for example, I would like the work method to be secured. So I'm going to take the security aspect, and I'm going to decorate this method with the security aspect attribute. And that's all there is to it right now. From now on, whenever this method is called, this will kick in, because on method entry, this method will get triggered. Not really triggered, it will just be there, and it will run for me. It will get invoked, and this is what will happen. So let's save this. And let's go to my form again. And here, I'm going to just set the thread principle. Again, I'm going to have to resolve this by system threading. And this with using the security principle. So here I have now a user set for my current thread. And this user is an administrator. So when I run my program, you can see that everything works as normal, as expected. But for example, let's say that my user is not an administrator, is just an editor. And now when I run it, so the security aspect will kick in. And if I try to invoke the read method, okay, probably the second one, the work method, we get an exception thrown. You are not allowed to run this method. And it will not continue. It's as if it got intercepted here, although I didn't really have to do anything. Just build the specific aspect that I need and decorate the right method. And that's how you can just inject it into a very big project, minimum work, and you have a lot of power in your hand. So this concludes this quick tutorial about aspect-oriented programming, why it's good for you, and what makes PostSharp so powerful and how easy it is to start working with it. I hope you enjoyed it.